Okay, students, this is lesson 4-7, starting on page 295. Let me share my screen with you. All right, so um, this is on sequences and functions, okay? So let's take a look. A sequence is an ordered list of numbers that often form a pattern. Basically, you can just think about it as just numbers in order, okay? So here's some examples of different sequences. There's 1, 3, 5, 7, 9, 11, 13, and 15, and so on. Okay? You could try to guess what the next term would be. Here's another one. 5, 10, 15, 20, 25, 30, 35, 40. You can guess what the next term would be there. The next one is 1, 4, 9, 16, 25, 36, 49, 64. Now that one might be a little bit harder, but see if you can guess to figure out what the next term is. We'll go over that in a minute. The next one is 0, 1, 2, 3, 4, 5, 6, 7. And that's another sequence. It's probably pretty easy to figure out what the next one there is going to be. The next one is 1, 2, 4, 8, 16, 32, 64, 128. Okay, and again, to try to figure out the next term. Now, I want to talk about two different types of sequences, but we'll mostly be talking about arithmetic sequences. Now, you can say arithmetic if you're talking about the name of something, like a noun, but if you're describing it like an adjective, then you would say arithmetic. So you can use it either way, an arithmetic sequence or arithmetic sequence. But normally if you're talking about the actual happening or doing of it, you would say arithmetic because it's describing what's going on. Okay? I guess that would be an adverb, not an adjective. Either way, an arithmetic sequence has a common difference. What do I mean by that? To get to the next term, you add the same number over again. I used n for the word number. So for example, that could be plus 2. Now let's take a look at the sequence that we have here. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. So our rule here would be plus 2. So this would be an arithmetic sequence. Okay? A geometric sequence has a common ratio, which means that you multiply to get the next term. So in that case, it would be times n. It could be possibly times 2. Okay? So let's take a look at all these different sequences and see what we come up with to get to the next number. So 5 plus 5 is 10. 10 plus 5 is 15. 15 plus 5 is 20. So each time I do plus 5, so my rule would be plus 5, and it's consistent all the way through, so that's an arithmetic sequence. Okay. Let's take a look at the next one. 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 7 is 16. 16 plus 9 is 25. This is not an arithmetic sequence. But it's interesting. You might notice here that the common difference, or that the difference here, it's not common, is the same as this first set of numbers. Okay? From 0 to 1 is 1. From 1 to 4 is 3. From 4 to 9 is 5. From 9 to 16 is 7. So this one's not arithmetic, so there's no specific rule that I can write down that's not very complicated. So let's look at this sequence. 0, 1, 2, 3, 4, 5, 6, 7. Yep, you guessed that the next number should be 8. So to add this one, I just add 1. So yes, it is an arithmetic sequence. Okay. Now let's take a look at the next one. 1 plus 2, or 1 plus 1 is 2. 2 plus 1 is not 4, but 2 plus 3. Okay, that one's not looking like it's an arithmetic sequence. But Let's try something else. Let's look at the geometric sequence. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So each time I multiply by 2. So I go times 2, so that one would be a geometric sequence. Okay. So we're mostly going to be talking about arithmetic sequences in this lesson. So I just wanted you to see both types. Okay. So here, this was an arithmetic sequence because you added 2 each time to get the next number. Here you add 5 each time. This one's not, so there's no real formula that I can use to determine what the next number would be. By the way, if you haven't figured it out, these are the perfect square numbers. So the next one would be 9 times 9, which is 81. Okay, just in case you were not figuring it out. See, you have 9 times 9, 8 times 8, 7 times 7, 6 times 6, 5 times 5, and so on. This one is an arithmetic sequence. Obviously, it's just regular counting numbers. So under the category of whole numbers, so you just add 1 each time. And this one's a geometric sequence because we multiply by 2 to get to the next term. Okay? So I also want to remind you, each number in a sequence is called the next term of the sequence. So 4 would be a term of the sequence, 5 would be the next term of the sequence. So each number is referred to as a term. Okay? Now, there is a rule, or basically it's a formula for solving an arithmetic sequence. I want to go into what that is. Okay? And it's a to the nth term is equal to a, the first term, plus, parentheses, n minus 1 times d. Now let me say what each of these mean. Nth term just means the numbers term, okay? For example, this is the 4th term, even though it's number 3 because we started at 0. Let's count 1, 2, 3, 4. So this would be the 4th term. So to find the 4th term in a set of numbers, then I would, call that my nth term, okay? So, continuing on, so A1 would be the first term in the sequence. So using this sequence, my first term is 0, okay? The term number is the number of the term, so in that case it would be the 4th term because 3 is the 4th term in the sequence. And D would be the common difference. So in this sequence, that would be plus 1, okay? Now, in order to find it, you would just plug in the numbers in this particular sequence and then you can solve, okay? Now, I set up a problem here for you. It's actually in the book. It's problem 32 on page 299. So I'm going to go ahead and solve this one for you just so that you can see. First, write the formula over again. A to the nth is equal to a to the first term plus, parentheses, n minus 1 times d, meaning the common difference. So I just rewrote the formula. Now I'm going to plug in some numbers. Okay, so let's say you have a sequence and its first term happens to be 5. Well, look at this one. This sequence, the first term is 5. Okay, and let's say I want to find out what the 2nd, 4th, and 11th terms are in this particular sequence. So the number n, I would substitute it as the 2nd, number 2, the 4th, and the 11th terms of the sequence. Now, when I substitute in the numbers, I'm going to substitute it in here. Now, I want to remind you, everything that's isolated on the equals sign, the left side of the equal sign here, I'm not having to solve this. This is just kind of telling me what it is that I'm doing. Trying to find the arithmetic sequence of the 2nd term, arithmetic sequence of the 4th term, arithmetic sequence of the 11th term, to find out what those numbers would be. Okay, So use order of operations to solve. So I have 2 minus 1 equals 1. The next step is to multiply. 1 times negative 3 would be negative 3, and negative 3 plus 5 would be 2. So my solution is this, and I could write it as the arithmetic sequence of the second term is 2. Okay, now let's look at this one. My fourth term, I would go 4 minus 1 is 3. 3 times negative 3 would be negative 9. Negative 9 plus 5 would be negative 4. So I could say that in this arithmetic sequence, the arithmetic of the fourth term would be negative 4. Okay? Now in this given one, let's find the 11th term. 11 minus 1 is 10. 10 times negative 3 is negative 30. Negative 30 plus 5 would be negative 25. So the a to the 11th term would be negative 25. Okay? Now, in this particular question, normally you're not going to be having a negative difference. And again, that would be the difference in the terms as demonstrated up here would be like this number, what the rule is. I add 2 to get to the next term. I add 5 to get the next term. I add 1 to get the next term. So most of them, you're not going to necessarily add negative 3. I just want you to understand what that number is and where it comes from. Okay? So again, let me just review. D is the common difference, meaning the rule or what number you add to get to the next term. Okay? N is the term number, and it's also repeated here in sort of like the part that tells you what it is that you're doing. And A1 means the first term of the sequence. So whatever number starts the sequence would be the number that goes there. Okay? So given that we know that the sequence starts at 5 and the common difference is negative 3, meaning that each term it goes down 3, then what you can do is just plug in the term numbers that you want. For the second term, I plugged in 2. For the fourth term, I plugged in 4. For the 11th term, I plugged in 11. Once those are plugged in, then just solve using order of operations to get your answer. And I want to remind you, everything to the left of the parentheses here is just a statement of what it is that you're doing. You don't actually have to try to solve for A and divide by 2 or anything like that, okay? Hope that makes it clear, and thank you very much.